G'day, welcome. Hello everyone. Rob Macbeth here. Today we're going to learn about states of matter, lesson 2. We'll be looking at the core example of solids, liquids and gases. We'll be looking at core example number 2. Describe the structure of solids, liquids and gases in terms of particles, separation, arrangement and motion. Let's begin. So I'd like to pose to you a couple of questions. You can answer them if you like. Don't be scared, or you can not answer them and just listen. I'd like to pose the following questions. What is a solid, you ask? What's the difference between a solid and a liquid in the structural state? Have you ever thought about that? How are particles arranged, and why are they arranged this way? How do particles stick together? How do they stay together? Do these particles move? And if so, how much do they move, and why? These are the questions I posed you, and I'll allow you a little bit of time to pause and perhaps think about them yourself. Now, what do I have in front of me? I have 3 states of water. On the left-hand side, we have solid, ice. In the middle, we have water. And if you can imagine, on the right-hand side, water vapor or steam as we know it. Now, according to the learning outcomes, we want to know about solids, liquids and gases and their characteristic in terms of their arrangement, their structure and their motion. Now solids are ordered arrangement. They have strong forces of attraction and they have fixed vibrations about their center. Now the reason why solids have strong forces of attraction is because they're in a well-ordered structure and they're close together. And these attractive forces, when they combine, are very strong indeed. Now we go on to the next state, liquid. Now liquid, the particles are slightly further apart and they're able to slide over one another. They're an irregular arrangement and they have weaker forces. Now the weaker forces are due, using the particle model theory, is due to they're slightly further apart. In like solids, they're together, well ordered. In liquids, they are disordered. Now we go on to gas. Now gases their particles are far apart, very far apart indeed. They've got high kinetic energy and they've got, as a consequence of being far apart, very low forces of attraction. Now when the particles do collide, they then travel at high speeds in random directions. So that's what you need to know about the arrangement, structure and motion according to the learning outcome number 2 in the core part of the 0620 chemical syllabus. Now I have a little sheet here where I want you to answer this question about solids, liquids and gases in terms of the states of matter. The question here is, in the boxes below, draw in the particles in a liquid and a gas. The solid has been done for you. So the solid's been done. What I want you to do is, if you can, a piece of paper, and you draw in what the liquid particles look like and what the gas particles look like. Pause the video and have a go. So here is the answers to the question above. So hopefully you drew the liquid part and the gas part. The liquid part, you should have drawn particles about the same size as over here in the solid, making sure some are touching and some are not, and then making these little dashes to give the impression that it's vibrating and moving. Remember, the particles combine and then detach, and that gives it ability to move and roll over one another to become a liquid. Over here, gas, same size particles again, put these little dashes in, and that gives the impression that they are not only fast moving, but you can also see they're a great distance apart. If you did that, well done. That would be a great effort from you. Now, just to confirm what you have learned this short lesson, we're going to do a quick 3, just reading through the question. Number 1 says, which change of state involves particles losing energy and moving closer together? You can circle letters A, B, C, or D. So we've got A, gas to liquid, B, liquid to solid, C, solid to liquid, and finally D, liquid to gas. Question 2 is the table shows melting and boiling points for 4 substances. In which are the melting and boiling points of the particles in an ordered arrangement at room temperature? Circle the letter A, B, C, or D. So your possible answers could be A, melting point minus 115 degrees Celsius, 79 degrees boiling point, B, minus 91 degrees Celsius, or boiling point minus 88, C, 80 degrees Celsius melting point, boiling point 218, and D, minus 23 degrees Celsius, up to the boiling point of 77 degrees Celsius. And the final question, describe the structure of a gas in terms of particle separation, arrangement, and motion. So pause this video and allow yourself 3 to 4 minutes to finish off the questions. Have a go. I hope you've had a go at answering those 3 questions. Here are the answers. So number 1, which change of state involves particles losing energy and moving close together? Circle letter A, B, C, or D. Now the 2 answers are these: gas to a liquid and liquid to a solid. If you got that right, well done. You did a super effort. Let's have a look at number 2. The table shows melting and boiling points for 4 substances. In which are the particles in an ordered arrangement at room temperature? Now I'd like to point out that ordered arrangement at room temperature usually means a solid at around about 20-25 degrees. So the answer here is C. Now if you remember, a melting point is when a solid changes to a liquid. So above 80 degrees it's a liquid, all the way up to 217.9918, and then above 218 or 18 above is the boiling point. So anything below this, it will be a solid. And that adds nicely to the part of the question where it said ordered arrangement at room temperature. And room temperature is usually 20 to 25 degrees. Okay, the last bit here, I'm just going to move up. And we've got question 3. Describe the structure of a gas in terms of the particle separation, arrangement, and motion. So 3 marks for this particular question. Gas particles are far apart, great distance. Gas particles are fast moving, traveling in random directions in a constantly changing irregular form. Well done if you've got one of those questions done. Great if you got 2 of those questions done. Awesome if you got all 3 questions done. Well done. Thank you very much for watching the second installment of States of Matter, Solids, Liquids and Gases. If you like these videos, please press the like and subscribe at the end of this YouTube. Thank you for your time and effort. It's much appreciated.